So we'll complete the questions of motion straight line today. Okay. So these 3 days, little bit, again, maybe less time, guys. 1 hour, 15 minutes, 1 hour, 15 minutes. I'll cover it up on Sunday. I'll take a big session, guys. Maybe 4.5 or 5 hour session I'll take on Sunday. But for these 3 days, today's Thursday, I guess. Thursday, Friday, Saturday. Hopefully we'll have for less time, guys. Is the board visible, all of you? Is the board visible, everyone?
Yes.
Right. So let us quickly complete the questions of motion in straight line. Okay. Which of the following statements is or are true? They are saying a body can have constant speed with varying velocity. Is it correct? Can a body have constant speed with varying velocity? Yes, it is correct statement. Right. That would be the case of uniform circular motion. So this is possible in which motion again? In uniform circular motion, speed remains constant, but velocity keeps on changing in direction. So it is possibility for a body to move with constant speed but have varying velocity. So this is a correct statement. A body can have constant velocity with varying speed. No, guys, it cannot be correct again. If velocity is constant at every instant, magnitude of speed, magnitude of velocity should be same again. Constant velocity means magnitude should be same and direction should be same. So can a body have constant velocity with varying speed? No, it can never have constant velocity with varying speed. A body can have velocity without acceleration. Can it have, again, whenever it is moving with constant velocity? Is this correct statement? Yes or no? It is also correct statement. No acceleration means it is going to move with constant speed, right? A body can have acceleration without having velocity. Is this correct statement? A body can have acceleration without having velocity. Yes, it is also correct statement. Suppose if you throw the object vertically upwards, at the highest point its velocity is 0, but it has an acceleration which is equal to acceleration due to gravity. So which out of these statements are correct? A is correct, C is correct, and D is correct, guys. Right? B will be wrong statement. A body can have constant speed with varying velocity. That would be a case of uniform circular motion. If a body has constant velocity, it has varying speed is a wrong statement. A body can have velocity without acceleration. Yes, when it is moving with constant velocity. A body can have acceleration without having velocity. Yes, whenever the object is at highest point, its velocity is 0, but it will be moving under the effect of gravity. Clear? Is that clear, everyone?
Yes.
Right. Next question, if you see, they have given position of a particle is varying. What would be the position of the particle when it achieves maximum speed? So what is position given? It is given as 9t square minus t cube. So position is varying with time, guys. So can I write velocity as dx divided by dt? Yes or no, all of you? So I can also write it as d by dt of 9t square minus t cube. So what will velocity be? I can separate it. I can write it as derivative of 9t square minus derivative of t cube. So what will I get velocity, beta? 9 I can take outside. Derivative of t square minus derivative of t cube you are going to obtain. What is derivative of t square? So v can be written as 9 into derivative of t square will be 2t minus this will be 3t square, guys. The velocity I'll get it as 18t minus 3t square. Yes or no? अरे हेमंत का ఎన్ని ఐడియల్ తో లాగిన్ అవుతారా भाई? The velocity is 18t minus 3t square. What they are saying? They are saying what would be the position of the particle when it achieves the maximum speed along positive x-axis. What is speed at any instant? Speed at any instant is called as instantaneous speed. And instantaneous speed will always be equal to magnitude of instantaneous velocity, as I've said it yesterday, guys. So for maximum velocity, always remember, for any quantity to be maximum, for maximum velocity, let us say, guys, what is the condition? The first derivative should be equal to 0. It means derivative of v should be 0. So what we can write? Derivative of 18t minus 3t square should be equal to 0. So I can write it as derivative of 18t minus derivative of 3t square should be equal to what, beta? Should be equal to 0. So 18 is a constant value, can be brought outside. Derivative of t with respect to t minus 3 into derivative of t square should be equal to what? 0. So 18 minus 3 into 2t you will get, which will be equal to 0. 18 minus 60, I can say it as 0. 60 value will be 18. So at how much time will you have maximum speed or maximum velocity? We are going to have maximum speed or maximum velocity at t is equal to 3 seconds. So at that particular time, they're asking what is the position. So I'll directly write position at t is equal to 3 seconds. How much will it be? 9 into 3 square minus 3 cube, right? 81 minus 27 you will get, beta. 87 minus 27 will be how much? 54 meters. Clear, everyone? Yes or no? Whenever they are asking you to find maximum value, or if a quantity has maximum value, then its first derivative should be equated to 0. So speed is maximum. What is speed at any instant? Instantaneous speed. Instantaneous speed will always be equal to magnitude of instantaneous velocity. So for maximum velocity, I can differentiate velocity and equate it to 0. So I will get maximum velocity at 3 seconds. At 3 seconds, the position will be 54 meters. Clear, all of you? Yes or no?
Yes, sir.
Let us move to the next question. Boy is walking 3 kilometers on a straight road from his home to market 3 kilometers away with a speed 6 kilometers per hour. He stays at market for 20 minutes and returns home back with speed 6 kilometers per hour. Average speed over round trip, they are saying. So overall, what is the average speed? Basically, how do you define average speed? Average speed, is it given as the ratio of total distance divided by total time or not? Yes or no, guys? Yes. So how much distance did it cover? So it has covered from his home to market 3 kilometers away. Then he stays at the market for 20 minutes and again he is returning back at a speed 6 kilometers per hour. So overall, how much distance did he travel? 3 kilometers from home to market and another 3 kilometers from market to home. What is the total time it is taking? First 3 kilometers he has covered with 6 kilometers per hour. Yes or no? So what is the time taken? 3 by 6 you can write. Plus, while he is returning back again at 6 kilometers per hour, 3 by 6 you can write. But if you also see, 20 minutes he was there in the market only. So 20 minutes means, is it one third of an hour or not? So plus you can write one third of an hour. So what will you get average speed as, beta? You will get it as 6 kilometers divided by 3 by 6, and 3 by 6 is 1 by 2 plus 1 by 2, which is 1. 1 plus 1 by 3 I'll get, which is 4 by 3, guys. So 6 divided by 4 by 3 I'm going to obtain, which will be 18 divided by 4. The average speed I'm going to get it as 4.5 kilometer per hour. Clear, everyone? Yes or no? Basic logic. Average speed will be given as total distance divided by total time. So in a round trip, he has covered 6 kilometers. First 3 kilometers he traveled with 6 kilometer per hour. Again, next 3 kilometers also he traveled with 6 kilometer per hour. But there is a waiting period of 20 minutes. We should include that also, guys. Understood, everyone? I hope it is clear. Right. Motion of a particle described by an equation. There is a certain motion, it seems, described by an equation. So it is moving along x direction only, guys. It is given as at plus bt square. Instantaneous speed they are asking. See, position is given to us. Can I find velocity at any instant? What is velocity at any instant, beta? Dx by dt, which we will get it as d by dt of at plus bt square. So I'm directly writing the differentiation part here. So what is velocity at any instant? It is a plus 2bt. Is this our velocity or not? Right? If I want to find magnitude of velocity at any instant, will it be instantaneous speed? Yes. So they are asking us to find out speed at t is equal to 3 seconds. At a particular instant, whatever is the magnitude of velocity, that will be speed only again. So I can write it as a plus 2b into 3, which I will get it as a plus 6b. So a is given as how much? 15. Right? B is given as how much? 3. So 15 plus 18, how much is it going to be, guys? 33, is it? We'll get it as 33 centimeter per second. Clear, everyone? Direct case again. Understood, all of you? I hope you understood. Instantaneous speed will always be magnitude of instantaneous velocity. How will you find velocity? If position time graph is given, or if position variation is given with time, then I'll differentiate position in order to obtain velocity at any instant. Clear? Right. Body starts to fall from rest from a large height. T1, T2, T3 are the time taken by the body to cover successive equal distances. What is the ratio of T1 is to T2 is to T3 they are saying? Again, it's a very important case, guys. If I look at certain situation, let us imagine object is dropped from a large height. I don't know what is the height, but it's covering equal distances. So from here to here, it took T1 time. From here to here, it took T2 time. From here to here, it took T3 time. So what distance did it cover? It has covered. So it is falling under the effect of gravity, guys. So while it is falling under the effect of gravity from large height, it seems T1, T2, T3 are time taken by the body to cover equal distances. Very important case. It has covered S distance here, S distance here, S distance here. And during the entire motion, is it going to move under the effect of gravity? Yes. So let us say here initially it is dropped. U is equal to 0. So what I can tell beta, from here to here, it is taking how much time? T1 time. From here to here, it is taking T2 time. From here to here, it is taking T3 time. They're asking the ratios, guys. Now always remember, in case of free fall means object released under the effect of gravity. Okay. Initial velocity will be anyhow 0. Always remember, distance traveled in free fall in t seconds will be given as half g t square. What will it be given as? Half g t square, guys. Now, what I'll do, I'll first find t1, right? It has covered how much distance? S distance. So, what will I get? S value will be half into g into t1 square. So, I can write t1 square value as 2s divided by g. So what will T1 value be beta? Root over 2s divided by g. But if I want to find T2, guys, here there is a twist again. If I want to find T2, first I need to find time taken to cover 2s distance, then time taken to cover s distance. So what is the T2 value here? Again, how much distance it is covering? 2s distance. For 2s distance, let us say 2s will be equal to half g into, let us say, some t dash square beta. So what will I get t dash square as? T dash square I'll get it as 4s divided by g, or I'll write t dash value as, if you want you can take it as root over 2 into root over 2s divided by g. Can I take it as root 2 times of t1 beta? Yes or no? So what is the t2 now? T2 value will get it as time taken to cover 2s distance minus time taken to cover s distance, which is t dash minus t1. So t dash is root 2 into t1 minus t1. So I'll get t2 value as root 2 minus 1 into t1. Did you understand, all of you? Did you understand? Next, if I want to find t3, how will I find t3 beta? Can I write it is the total time taken to cover how much distance? 3s distance minus time taken to cover 2s distance or not? The same manner if you just do it. So 3s will be half gt square. If you do, you will get the value of t3 as, how much will I get beta? Root 3 minus root 2 into t1. So what is the ratio of t1 is to t2 is to t3? You will get the ratio of t1 is to t2 is to t3 as 1 is to root 2 is to 1 is to root 3 minus root 2. Understood, all of you? Did you understand? Always remember, this is an important formula beta. Whenever object is dropped from a certain height, the distance covered in t seconds, let us say s is the distance covered in t seconds, that s will be given as half g t square. Understood, all of you? Whenever object is dropped from a certain height under the effect of gravity, distance covered in t seconds will be given as half g t square. Understood, everyone? Yes or no?
Yes.
Just give me a second, guys. Am I audible? So please remember this, guys, because it's a very important formula. Distance traveled in t seconds during free fall will be given as half gt square. So what is the ratio of distances traveled, time taken to travel equal distances? It is 1 is to root 2 minus 1 is to root 3 minus root 2. Then you will get what, guys? If you just look at the case again, you will get it as root 4 minus root 3. Then root 5 minus root 4. That ratio you will get. But Galileo's law of odd numbers, what it is stating? Time taken to cover, what is the ratio again? Law of odd numbers again. 1 is to 3 is to 5 is to 7 is to 9 again. So that also you can remember again. But as of now, this case is very important because Galileo's law of odd numbers, most of them will be writing it correctly. But this case, everyone will do wrong, guys. This case, let us see. Which of the following statements is incorrect regarding motion of particle along a straight line? VT graph is a straight line inclined to time axis for uniform acceleration. What do we obtain from VT graph? First and foremost thing, velocity versus time graph is given. In general, slope will give acceleration. Slope between 2 points, average acceleration. Slope at a particular point, instantaneous acceleration. Area will give displacement as well as distance. Yes or no? So VT graph is a straight line, it seems. Straight line will have constant slope or not? The constant slope means acceleration will be uniform. Is this correct statement? Yes, it is a correct statement. Right? Similarly, VT graph is a parabola if motion is uniformly accelerated. Is that correct now? If first statement is correct, will fourth statement be correct, guys? VT graph is parabola, it seems. No, it is a straight line inclined to time axis for uniform acceleration, correct? Because straight line will have constant slope, guys. Slope of VT graph will give acceleration. Okay. So this would be wrong statement again. VT graph is parabola if motion is uniformly accelerated is wrong statement. Let us see the other two graphs also. XT graph is a parabola if motion is uniformly accelerated. So yes or no? Because how will you get acceleration again from XT graph? Rate of change in position will be acceleration. So XT graph is parabola means x is proportional to t square. So velocity, it is given as dx by dt. It will be proportional to t. Acceleration, we know it is given as dv by dt. It will just be a constant value. Yes or no? So if position and time graph is following a parabola, then it will certainly be a uniformly accelerated motion. So second statement is also correct statement. Okay. Now, xt graph is a straight line inclined to time axis if the motion is uniform and acceleration is zero. Is that correct? Yes or no? Xt graph is straight line means x is directly proportional to t. So what will you get? V as dx by dt. So slope again here you will get it as a constant value. So what will acceleration be? Zero. This is also correct statement, guys. So xt graph is a straight line inclined to time axis for uniform motion, and acceleration will anyhow be zero. So which one will be wrong here? Fourth one will be the wrong statement or incorrect statement. Clear, everyone? Yes or no? Let us talk about the next question. Particle moving along a straight line. We were doing questions from the very beginning yesterday, right? But see, I don't know. I just shifted to the last question. I'm going from last to first, guys. The reason is while I was doing first question yesterday, while I was solving the question, I was really feeling very tired while solving such type of questions. So maybe I thought if I continue that same rhythm, I'll be tired only, and the flow of the class will be missed. So I thought we can better do it by taking from the last. Right. Let us see next question, guys. A particle moving along a straight line has velocity v when it covers a distance x along positive x-axis. Relation between the quantities when the velocity of the particle is 1 meter per second. What is the acceleration they're asking? So how is velocity varying, beta? Velocity is given as root over 49 plus x. How to solve such type of questions? It's a very important case again. I'll square it, guys. So v square I will take it as 49 plus x. Okay. Now what I'll do is, on differentiating both sides with respect to x, it's very important again. On differentiating with respect to what? With respect to x again. So what we can write? D by dx of v square will be equal to d by dx of 49 plus x. See, velocity is varying with x, guys. So is it in the form derivative of x power n or not? So I'll get n into x power n minus 1 into d by dx of x we can write. And here I'll get it as d by dx of 49 plus d by dx of x. So what will this be? 2v into dv by dx. Derivative of 49 will anyhow be 0. Derivative of x with respect to x is 1 only. So what will I get? V into dv by dx? It will be half. What is this v into dv by dx, guys? Is it acceleration or not? Yes, it is acceleration. So from this, what we can write? Acceleration will be half meter, which is a constant acceleration. So you take any speed, the acceleration is going to remain constant, which is 0.5 meter per second square. Understood, all of you? Whenever velocity is varying with position, if velocity is varying with time, I'll write acceleration as dv by dt. But when velocity is varying with position, then I'm going to write it as acceleration. I'm going to write it as v into dv by dx. These two are very, very important. Velocity varying with time, acceleration dv by dt. Velocity varying with position, acceleration v into dv by dx. Okay, is that clear? I hope it is clear. The area under acceleration time graph, what is it going to give? Area covered under acceleration time graph, will it give velocity? What is it going to give? Change in velocity. I've told you many times, guys. How again? We write acceleration as dv divided by dt. In general, let us say, if it is straight line motion. So what we can write dv value as a into dt. Differentiation is there. In order to remove differentiation, what will we apply? We are going to apply integration. So let us say t is equal to 0. Initial velocity is there, vi. After a certain time, t is equal to t. There is some final velocity v. So what is integral dv beta? V. From where to where? From v initial to v final. Again, integral of a dot dt from 0 to t. Right? So what is integral of a dot dt? Is it going to give us area or not? If I substitute the limits, what will I get here? V final minus v initial will be integral of a dot dt from 0 to t. So what is v final minus v initial? Delta v beta. So always remember, area covered under acceleration versus time graph is going to give us change in velocity, guys. It is not going to give velocity. It gives us change in velocity. It's a very, very important case again. Right, let us see this question. Two ends of a train moving at constant acceleration pass a point with speed 12 meter per second and 24 meter per second. The speed with which the midpoint of the train passes the same point. Direct case again. Let us imagine I am taking one cross section, guys. I am taking one cross section. Let us take this is the point. Okay. The head of the tail, the head of the train, while it is crossing this point, head is moving with some speed. How much beta? 12 meter per second. So tail is somewhere over here. It is moving with constant acceleration. Midpoint is here. Okay. In the same manner, while tail is crossing, midpoint is here, head is here. While tail is crossing, it is doing so with what speed beta? 24 meter per second. Now they're asking, if midpoint is crossing, what should be the speed? There's a direct formula for that, right? Which is given as under root of va square plus vb square divided by 2. But how, I'll tell you. So is it moving under uniform acceleration or not? Yes, it is going to move under uniform acceleration. Right. So what we will do, first I'll apply. I'll take it little bit larger, guys. So I'll take one particular section, something like this. Okay. Here you have the head of the tail, head of the train. Here you have the tail of the train. Here is the midpoint of the train. This is head. This is midpoint. This is tail. So while it is crossing this junction, it has a speed of Let us say u, which is 12 meter per second. It is moving with constant acceleration. Let us imagine the entire train is accelerating with acceleration. Now, when the tail is crossing this point, the midpoint will be here, head will be here. So when tail is crossing this point, it is doing so with some speed 24 meter per second, let us say. Now what they are saying, when midpoint is crossing, what would be the speed with which it is going to cross? So let us say the speed is v dash. Okay. Now length of the train, if I assume it is some L, or let us say it is 2L. So from here to here, you will get it as L. From here to here also you'll get it as L. What I'll do, I'll apply, because it is uniform acceleration, guys, it's moving with constant acceleration, it's given. I'll apply v bar square is equal to u bar square plus 2a bar s bar. First I'll apply between head and midpoint, then I'll apply between midpoint and tail. Okay. So final velocity, again, if I say between head and midpoint, if I take, head is moving with u, midpoint is moving with v dash. What we can write, beta? V dash square will be equal to u square plus 2a into, what is the distance covered as it moves from head to, as the train moves head to midpoint, did it cover L distance or not? So what I can write, v dash square, we got something like this. Then I'm going to apply, this is between what and what? This is between head and midpoint. Now I'm going to apply between midpoint and tail. So midpoint is crossing with v dash, tail is crossing with v. So what will I do now? I'm going to apply v square will be equal to v bar square plus 2a. Again, between midpoint and tail also, how much is the distance again? L. So from this, what we can write, v square minus v bar square will be equal to 2al. So what I'll do, I'll take this 2al and substitute here, guys. So if we substitute it there, what are we going to obtain? If we substitute it there, I'm going to obtain something like this. This part, if you take it here, so v dash square will be u square plus, right, v square minus v dash square. So I can write 2 times of v dash square will be v square plus u square. So what will v dash square be, beta? V dash square will be v square plus u square divided by 2. What will v dash value be? Again, it's a direct case, guys. Under root of v square plus u square divided by 2. Right? So what I can write v dash value as? It's a very important case again. Under root of v square plus u square divided by 2 is a very important case. So what is v given? V is given as 24, no? So I can write 24 square plus 12 square divided by 2. If I take 12 square, because 24 can be written as 2 into 12. So 2 square, if you take common, I will get it as, I think 4, I think 4 plus 1, root 5 by 2 you will get. Root 5 by 2 into 12 you will get. So v dash value will be 12 into root 5 divided by 2. This would be the speed. Clear, everyone? 12 square I have taken common, guys. Or if you take 24 square, you know it is how much? 576. Whatever it is, huh? 12 root 5 by 2 you will get. Understood, everyone? What is 12 root 5 by 2? How much you are getting? You just see. Yes or no? I think I've done it correctly. You won't see 12 square. If I take common in first quantity, you'll be left out with 4. 4 plus 1 is 5. Root 5 by 2 you'll get. 2.5 we have. So near about, you can take root 3 is 1.7, no? 1.5 you take, guys. Near about 17, 19 or 18, 19 you will get. So I think 19 should be the answer for that. 19 or 20. You just check it, okay? Clear, everyone? I hope you understood the question. It is direct case of constant acceleration only, where we have applied the third equation of motion. V bar square is equal to u bar square plus 2a bar s bar. Did you understand, all of you? I hope you have. Then for velocity time graph, what is the average velocity of the object during 7 seconds they're asking? How do you find average velocity, beta? Again, average velocity is simply given as total displacement divided by total time. Which graph is given? Velocity time graph is given. So how will you calculate the displacement? From velocity time graph, can you find out displacement? Are from velocity time graph, can you find out displacement? Yes, we can find out displacement. How can we find out displacement? By calculating area covered under which graph beta? Velocity versus time graph. So area covered under velocity versus time graph is going to give us the total displacement. Now please tell me, is this the area covered or not? Is it in the form of a trapezium beta? So how much will I get the area as? Half into height. How much is height? 10. Sum of parallel side, 1 you see this one. 7 to 1 here. One side is 7 to 1, which is 6. Plus other one is 5 to 3, which is 2. Total time is how much again? 7. So what will you get here? 840 by 7 you will get, guys, because 8 into 10 is 80 by 2, 40 by 7 you will get, which will be near about 5.7 meter per second. Understood, all of you? How do we obtain average velocity? Average velocity is given as the ratio of total displacement divided by total time taken. From velocity time graph, how will you obtain displacement? Area covered. Here, the entire area is above time axis, so it should be taken as positive only. So in this case, I can say, because entire area is above time axis, I can say that distance will be equal to magnitude of displacement for this case, guys. If the area is below time axis, for calculation of displacement, you will take that area as negative. But for calculation of distance, you will take it as positive itself. Clear? Understood, all of you? Yes or no, yaar? Acceleration of the body is given. They're asking you to find velocity, guys. So far as acceleration is given, is it varying with time or not? So if it is varying with time, I will directly write acceleration as dv by dt, guys. It can be given as 3t plus 4. So dv value, I'll get it as 3t plus 4 into dt. Differentiation is there. In order to remove differentiation, what should we apply? We'll apply integration, guys. Okay. Let us say initially it is starting from rest, because it's already given it is starting from rest. It means at t is equal to 0, velocity will be 0. They're asking to find velocity at 2 seconds. So at t is equal to 2, let us say velocity is v. So how will I write integral dv as? Integral dv will be v, guys, from where to where? 0 to v. Should be equal to, I can write integral u plus v again. So it will be integral 3t into dt plus integral 4 into dt. Limits you can apply from 0 to 2. This one also from 0 to 2. So v minus 0 will get 3 is a constant value. Constants can be brought outside beta. Right? Integral t will be how much here? It will be t square divided by 2. From where to where? 0 to 2. 4 is a constant value. Integral dt, what will you get? T. Again from where? 0 to 2. So v value can be taken as 3 into, if you substitute the limits, guys, 4 square by 2, 16 by 2, you will get it as, sorry, 2 square by 2, you will get it as 2 minus 0. This will anyhow, you will get it as 2 plus 4 into 2. So 3 2 6, 4 2 8. So overall answer should be how much beta? 14 meter per second. Understood, everyone? So if acceleration versus time graph is, or acceleration relation with time is given, I will write acceleration as dv by dt. Perform integration to find the velocity at any given instant. However, if acceleration versus position expression is given, if acceleration is varying with position, then I will write acceleration as v into dv by dx and perform integration again. Understood, all of you? Yes or no? I hope it is clear. Okay. Right. Let us see the next question. Object is dropped from the top of a tower. It travels 5 meters in the first second and 25 meters in the last second. The speed with which the object strikes the ground, they are saying. So please tell me, it has traveled how much distance in first second? 5 meters. And 25 meters in the last second. So what I can say, distance, suppose if I say if, let us imagine, if time of flight is equal to n seconds, so what I can say, distance traveled in nth second, last second is nothing but nth second beta. So what will I write it as? Can I write it as distance traveled in n seconds minus distance traveled in n minus 1 seconds or not? Yes or no, everyone? And what I've also told you, whenever object is dropped, what is distance traveled in t seconds? Half gt square. Right? So what is distance traveled in, suppose if time of flight is 5 seconds, let us say. What is distance traveled in fifth second? It will be distance traveled in 5 seconds minus distance traveled in 4 seconds or not? Yes or no, yaar? Right. So what is given here? Distance traveled in fifth second is given. How much is it given as? Sorry, last second is given, which is 25 meters. Will be equal to what will be distance traveled in n seconds in free fall? Can I write half g n square beta? Minus what will this be? Half g into n minus 1 whole square. Yes or no? Just now I have told you guys. Whenever object is dropped from a certain height, distance it is going to travel in t seconds is given as half gt square. Yes or no? What we can write, 25 value will be equal to g by 2, you can take like this, n square minus n minus 1 whole square you are getting. Okay. So what will I get? 25 will be equal to g by 2 will be 5 anyhow. So what is a square minus b square beta? Is it a plus b? Yes or no? Into a minus b or not? So 5 ones and 5 fives you will get anyhow. To which I can write it as 5 will be equal to this, you will get it as 2n minus 1, and n minus n will anyhow get cancelled, into 1 you will get. Okay. So what is 2n minus 1 we are going to obtain from this? If you take 2n minus 1, you will get 2n minus 1 as 2n minus 1 you will get it as 5, 2n value you will get it as 6, n value you will get it as 3 seconds. So what is the total time of flight beta? Total time of flight is given as 3 seconds. They're asking speed with which it is getting. So if it is dropped from a certain height h, what is the time of flight? I can write as root over 2h by g is equal to 3. Yes or no, all of you? Now what is speed with which it is going to hit the ground? It is root over 2gh, guys. So can I write it as g into root over 2h by g? Yes or no? So g value is anyhow 10. Root over 2h by g, we found it as 3. So answer should be 30 meter per second. Clear, everyone? What is distance traveled in last second? It will be distance traveled in entire, the whole time of flight minus distance traveled in time of flight minus 1. Clear? You can use the formula distance traveled in n second as u plus a by 2 into 2n minus 1 also. Did you understand? Answer should be 30 meter per second, guys. Clear? Understood, all of you?
Yes.
From top of a tower 100 meters high, a ball is dropped, and at the same time another ball is projected vertically up from the ground. Where will the two balls meet? They are saying. Again, very good question of relative motion again. There's a ball which is on the ground, let us say. This object is thrown vertically upwards with speed how much beta? 40 meter per second. Okay. Now there is another object somewhere at a distance 100 meters height. So what is separation between these two objects? It is 100 meters. Let us say the first object. This is second object. Right? So what is the distance? It is given as 100 meters. What has happened to first object? First object is dropped beta. So u value will be 0. What? So where are the two balls going to meet? They are saying. A very simple logic. Whether you take first object is dropped. Will it be moving under the effect of gravity? Even when you take second object, when object is thrown vertically upwards, again it will be pulled towards the center of the earth. The second object will also be moving, right, under the effect of gravity. So what is the relative acceleration between them, beta? Both have acceleration in downward, same direction. The relative acceleration will be how much, beta? 0. Right. So what we will do now? I will just analyze the case or if you don't want to write like that, then I'll, because two motions are then analyzing two motions is little bit difficult, I'll take with respect to second object, guys. With respect to second object means what should I do? Second object, what should we do, beta? Second object, we should stop. So are we stopping the second object? Yes. What all quantities are there to second object, I will give it to the first object in opposite direction. So second object has 40 meter per second in upward direction. So what I'll do, beta? I will give it to the first object in which direction? Downward direction. Right? For the second object had acceleration g in downward direction. What I'll do, beta? I'm going to give g in upward direction. So now you see relative acceleration. This g and this g will get cancelled out. First object, with what speed is it moving? So there is no acceleration at all, guys, here. So you have 40 meter per second. So obviously, is it going to move down or not? Yes. So in order to reach the second object is made to stand on the ground. There is no motion in second object because I'm analyzing the whole situation with respect to second object means I should stop second object. Second object should not move. Where is the second object? On the ground. Where is the first object? At a height 100 meters. Yes or no, guys? Now, is there any relative acceleration? Both of them will cancel out each other. There is no acceleration. So, is it going to move with a constant speed of 40 meter per second or not, guys? Yes. So, let us say it is starting at t is equal to 0. After what time it is meeting second object? Let us say after t seconds. So, what we can apply here? You know the distance, you know the speed. Can I write time taken as speed, distance divided by speed or not, guys? D by V you can take or S by V you can take. How much distance did it cover? 100 meters. With what speed is it covering? 40. So they are going to meet after how much time? They are going to meet after 2.5 seconds. Now for first object, what I'll do now, I'll write for first object. Is it moving? Is it just released or not? So whenever object is released, what is the distance it is going to cover in first t seconds? So I'll write S will be equal to half g t square. Yes or no? Which is half into g value is taken as 9.8 over here. T value is what here? 2.5. You can take 2.5 whole square. So which I'll get it as 4.9 into 2.5, 6.25 you will get. You can take almost 6 5s, 30 you are going to get. So 30 meters from the top. So how many meters? 5 6 30 only, no? Yes or no? This will be approximately 30.6 meters. So this is the distance traveled by the first object in order to reach the second object, right? And how much distance it is going to cover? 30.6 meters from the top. So answer should be second option. Clear all of you? Again, at a good concept of relative motion again. Both the first object and second object will move under the effect of gravity. There will not be any relative motion, right? Relative acceleration. Relative motion is there. Relative acceleration will not be there. So relative to second object, first object will be moving with constant speed of 40 meter per second. So after what time will it meet second object? After 2.5 seconds. So in 2.5 seconds, how much is the distance covered by first object with respect to ground? Half into g into 2.5 square, which will get 30.6 meters. So exactly 30.6 meters from the top, they are going to meet, or at a distance of what you can write, because total height is given as 100 meters, guys. You can take 69.4 meters from the ground. Understood? Is that clear? Yes or
Yes.
no? It's a good question, guys. Again,
Yes, sir.
a ball is thrown vertically upwards with velocity 20 meter per second from top of 25 meters high. What is given? A ball is thrown vertically upwards with velocity of 20 meter per second from the top of the tower. What is the maximum height reached by the ball from the ground? It seems from the ground they are asking. Again, direct question or not, guys? We can take something like this. From the ground, you can take, already tower is here. At what height it is from the ground? It is already at a height 25 meters. Now from here, what we are doing? We are projecting the object vertically upwards with speed 20 meter per second. Now forget about this height, guys. Now will this be a case of object projected vertically upwards or not? So what will happen? It will move up, reach maximum height, and it is again going to come down. So they may also ask you to find what is the time after which it is going to hit the ground. Let us say it started at t is equal to 0. It is going to hit the ground after t is equal to t. They may also ask you to find what is the speed with which it is going to hit the ground. Okay, guys, they may also ask you to find the speed with which it is going to hit the ground or time after which it is going to hit the ground. But now they are asking what is the maximum height. Now, please tell me from here till here, what will be the maximum height? Will it be u square divided by 2g? Whenever object is projected vertically upwards, it is u square divided by 2g. U value is given as 20 square divided by 2 into 10. Will I get it as 400 by 20 or not? Will this be 20 meters, beta? Yes. So from the top of the tower, the maximum height is 20 meters. But from the ground, how much it is? From ground, what is the maximum height of the object, beta? From ground, I can write 25 meters plus 20 meters, which you will get it as 45 meters, guys. Clear, everyone? Yes or no? Police jeep is chasing a certain culprit, it seems, going on motorcycle. Motorcycle crosses a turning at 20 meter per second. The jeep follows at speed 30 meter per second, crossing the turning 6 seconds later than the motorcycle. If they travel at constant speed, how far from the turning point jeep catches up the motorcycle, they are saying. So there is some turning point. Let us say here is the turning point, guys, and let us say they are moving in this manner. Okay. So first, uh, motorcycle crosses a turning at 20 meter per second. Jeep follows at 30 meter per second, crossing the turning 6 seconds later. So it means at t is equal to 0, the culprit will be here at t is equal to 0, and he is moving with what speed? 20 meter per second. Yes or no? This is situation at t is equal to 0. Now, after t is equal to 6 seconds, so t is equal to 6 seconds. Now, what is happening? The police jeep is crossing now. With what speed is it crossing? It is crossing with 30 meter per second. So, automatically it is clear that the car would have traveled for how much more time, beta? 6 seconds or not? Yes, this will be the case again. We've already done similar kind of question yesterday, guys. It's moving with constant speed. The car is also moving with constant speed. How much speed is it given as? 30 meter per second. As a jeep is 30 meter per second. Car is anyhow 20 meter per second. So this is 20 meter per second. Right. So what they are asking, how far from turning point jeep catches up the motorcycle? So for jeep to catch up the motorcycle, let us say they are catching up here. Right. So what I can say, from here to here, is this distance traveled by the motorcyclist or not? And from here to here, is it distance traveled by the jeep or not, beta? So what I can say here, distance traveled by the jeep will be equal to distance traveled um by the culprit plus this distance again. Now, how much is this distance? Please see. This particular culprit who is moving on a motorcycle, did he travel for 6 seconds more or not? So in 6 seconds, how much distance will it cover? 120 meters it is going to cover. Yes or no, all of you? Because it is moving with 20 meter per second. Let us say it started at the crossing at t is equal to 0 with 20 meter per second. So after 6 seconds, how much distance will it cover? 120 meters. Yes or no? So I can say distance traveled by jeep will be distance traveled by the cyclist plus 120. Understood, everyone? Yes or no? So they're asking after how much distance they are going to cross. So obviously it will be more than 120 meters, guys. Only one option is there, 360 meters you can consider. Clear, everyone? So let us say after what time they are crossing. Now Jeep is moving with how much speed? 30 speed. Let us say they are reaching or crossing each other after t seconds from the beginning. But Jeep has traveled 6 seconds less or not? So I'll write 30 into t minus 6 will be equal to, by the cyclist, how much distance it is covering? 20 into how much more distance it has covered, guys? From here to here, you see again. Already 6 seconds is this. Police jeep is chasing culprit going on motorcycle. The motorcycle crosses a turning at 20 meter per second. Okay. The jeep follows at speed of 30 meter per second, crossing the turning 6 seconds later than the motorcycle. If they travel at constant speed, how far from the turning point jeep catches up with the motorcycle? They are asking. So what is distance traveled by the cyclist, guys? How much distance did it cover? So it has to move from here to here, no? So did it travel for, this is anyhow 120. So how much will this distance be from here to here? This is t is equal to 0, t is equal to 6, right? From here to here, totally I took t is equal to t. So it has also traveled for t minus 6 seconds or not here? Yes or no, beta? Yes. It will also travel for t minus 6 seconds plus 120 you can write. So I'll get 10 into t minus 6 will be equal to 120. T minus 6 I'll get it as 12. So after what time will they meet, beta? After 18 seconds. So after 18 seconds from the beginning. Okay. So how much distance will be covered by the uh, car now? 180 meters or not? It is moving with what speed, beta? 20 meter per second. So will it cover 360 meters in 18 seconds? So it started here means it is going to cover totally 360 meters from the turning, guys, overall. Okay, so 360 meters should be the answer. If they travel at constant speed, how far from the turning point jeep catches up the motorcycle? So they are going to catch up after 18 seconds from the very beginning. So in 18 seconds, what is the distance traveled by the motorcyclist? 20 into 18 you can do, which is 360 meters. Understood, all of you? Yes or no, yaar? I hope it is clear.
So
Yes,
isn't it
sir.
360 meters total distance travel?
From turning point only, no? They are asking what is the, what they have given. Where is it? How far from turning point jeep catches up the motorcycle? So from turning point, it has to cover this much distance totally again. From here to here, which is 360.
Okay.
Next question, let us see. An insect crawling up a wall 6 centimeters up in first second, slides 4 centimeters down in next second. Yesterday we have done horizontal motion, I think yesterday. Today we are doing this type of motion again. So what they have given is overall in 2 seconds, how much distance will it cover? 2 centimeters or not? Right? It again crawls 6 centimeters in third second and again slides 4 centimeters downwards in 4 seconds. How long will the insect take to reach a hole in a wall at height 24 meters? Now please see, in one sequence, let us say the insect is here. In one sequence, how much displacement it is going to attain? Is it going to travel 2 centimeters or not? But this will happen in how much time? This will happen in 2 seconds time. In the next 2 seconds again, where will it be? Again, it has traveled 2 more centimeters or not? This is next 2 seconds. So from here to here again, you will get 2 seconds. Now, let us say this is y is equal to 0. Yes or no? This is y is equal to 0. This is y is equal to 2. This is y is equal to 4. Like that. Like that, guys. Can I say after a certain sequence, will it reach y is equal to 18? In how much time you see? In 2 seconds, 2 centimeters. In next 2 seconds, 4. So 18 seconds. What would be the situation here? Again, what is the overall time? Let us say it is starting at t is equal to 0 over here. What is the time it will take till here, beta? Will it take 18 seconds or not? Yes or no? In one sequence, 2 centimeters up. In the next sequence, 2 centimeters up. So let us say in order to reach 18 centimeters, should it continue the sequence for 9 times or not? So each sequence is for how much time? For 2 seconds. So you'll get it as 18 seconds. Now you see. Now, if it makes 6 centimeters up from here, if it is moving 6 centimeters up, guys, so directly will it fall at y is equal to 24 or not? Yes or no? Are you getting my point? So how much is the time taken here? From here to here, it will be only 1 second because you're taking one step only. You're not coming back 4 centimeters again back. So what is the overall time to reach from 0 to 18? It is 18 seconds. Now, once you have reached 18, now do you need to follow sequence? No, because from 18, if you move 6 centimeters up, directly will you fall in the hole or not? So plus what we can write 1 second. So overall the answer should be 19 seconds, guys. Clear everyone? It is also very good question again. Understood all of you? Yes or no, yaar? How many more questions are there? I think some questions are there. We'll quickly complete it. A motorboat covers a distance between two spots in a river, right? In 8 hours and 12 hours downstream and upstream. What is the time required by the boat to cover this distance in still water? So in downstream, it will take less time because speed will be both speed of the boat as well as speed of the river. So first case, if I say downstream, in downstream, what is the time taken? I can directly write it as distance between the 2 points divided by v plus u. So from this, what will I get, beta? V plus u value, I'll get it as d divided by t. In upstream, let us say time taken is t dash. In upstream, upstream means you are moving opposite direction of flow of water. So I can write it as v minus u. So implies what we can write here, beta? V minus u, I will write it as d divided by t dash. What are they asking? What is the time required by the boat to cover this distance in still water? Some distance it is covering, guys. So what we can take in still water? In still water, if I take, it is going to move with its own speed. In still water, we have t double dash, let us say. They are asking us to find what is d by v value, guys. Okay. Now, can I add both of them? If you add both of them from both of these, if you add both of them, what will I get, beta? V plus u plus v minus u. Will I get 2v or not? 2v will be d by t plus d by t dash. Yes or no? So what I can write? 2v will be equal to d into 1 by t plus 1 by t dash. So from this, can I write d by v value will be 2 divided by 1 by t plus 1 by t dash or not? To which I can write it as 2 divided by 1 by 8 plus 1 by 12. So 20 by 96 you will get, which is 2 into 96 divided by 20. Okay, 9.6 hours it will take in order to complete the distance between the 2 points in still water, guys. Did you understand? Downstream resultant velocity or resultant speed will be v plus u. Right? Upstream resultant speed will be v minus u. In still water, it will be only speed of the object, beta. What we have done, these two equations I have added. If I add, I'll get 2v is d by t plus d by t dash. And from this, I can write d by v as 2 divided by 1 by t plus 1 by t dash, which you will get 9.6 hours. Understood, everyone?
So what are V and U over here?
V is the speed of the boat. U is the speed of the stream.
Understood.
Clear?
And why are we taking it as V minus U when it is coming upstream?
Hmm?
Why are we taking it as V minus U when it is coming upstream?
Just a second. What you're saying? Why are we taking?
It has V minus U as a resultant speed when it is going upstream.
Are upstream means you are going against water. If you are going against water, it means your speed will be less, no?
Yes, sir. Correct.
That is the reason we take V minus U. Understood, all of you? Let us see the next question. If water drops are falling at regular intervals from a ceiling at a height of 80 meters from the floor, if drops are falling at an interval of 1 second, then height of the third drop from the floor when the first drop reaches the floor. So first of all, I need to find the time taken for each drop to hit the floor. Now, what is the time of flight when object is dropped from a certain height? Is it root over 2h by g or not? What we can write better? Root over 2 into 80 divided by 10, which is 160 by 10. We'll get root 16. So each drop will take how much time? 4 seconds time. So it means the first drop when it is hitting, if it is released at t is equal to 0, let us say this is our first drop, guys. After what time it is going to hit the ground? After 4 seconds. Now each drop will travel 1 second less or not? Yes. So automatically, where will the second drop be? The second drop, if I consider, right, will it be somewhere here at 3 seconds or not? Where will the third drop be? Third drop, if I consider, it will be at t is equal to how much beta? 2 seconds. Right. Similarly, where will the fourth drop be? Fourth drop, if I say, fourth drop will be somewhere over here, which will be at t is equal to 1 second. Fifth drop will be about to leave the tap, guys. I'm not saying t is equal to 1 second again. It would be traveling 1 second, guys. This is the fifth drop. Okay. So writing this is not correct again. T is equal to 1 second, 2 second, 3 second. I cannot write. If I am dropping the first drop at t is equal to 0, after what time will it hit the ground? After 4 seconds. It means second drop has traveled for how much time? For 3 seconds. Third drop has traveled for how much time? 2 seconds. Fourth drop has traveled for how much time? 1 second. Right? Fifth drop is about to leave the tap. Yes or no? It is about to leave the tap. Now they are asking about the third drop, I believe. Third drop distance when first drop reaches the floor. So if first drop is released at t is equal to 0, it is going to hit the floor after 4 seconds. It means second drop will travel for 3 seconds, third drop will travel for 2 seconds. So what is distance traveled in free fall again? As I said, please remember it. It is half g t square. So what is distance traveled by third drop beta in it has traveled for 2 seconds or not? It will be half into g into 2 square, which I will get it as 2g, which is 20 meters. Overall height is 80 meters. How much is the distance traveled by the third drop beta? Third drop from the tap has traveled 20 meters. Means from the ground, what height will it be at? It will be at 80 meters, guys. Clear, all of you? Height of the drop from the floor they are asking. Sorry, overall height is 80 meters, no? So it will be 60 meters. Understood, everyone? Is that clear? If I drop first drop at t is equal to 0, it will hit the ground after 4 seconds. And what is the time interval between each drop? 1 second. So second drop has traveled for 3 seconds. Third drop has traveled for 2 seconds. What is distance traveled in free fall? Half gt square, guys. So in 2 seconds, it will travel 20 meters. This 20 meters is height from the tap. They are asking height from the ground. Overall height is 80. It has traveled 20 meters from the tap. So it has automatically, it will be at a height 60 meters from the floor. Understood, all of you? Yes or no?
Yes, sir.
Displacement time graph is given. Choose the correct option, it seems, among the following. What is the situation, guys? Here, if you take this point and this point, how can you find velocity at any instant? Displacement time graph is given. by drawing a tangent slope at a particular point. So if I draw tangent here as well as here, what is the slope for both of these? 0. So at both these points, I can say that velocity will be how much beta? 0. So can I say the third statement is correct? Particle comes to rest momentarily twice. Can I say it is correct? Yes. So if third is correct, I need to check first one is correct or not. Now, again, as I have told you before, guys, displacement time graph is there. If you have something in this manner, ice cream cone, you have acceleration negative. Here you have acceleration positive, right? If you divide into this, whatever graph is given, guys, if I divide into, let us say, some three halves, guys, you take this half, you take this half, okay, four halves. I'm one, two, okay, three only you are going to get, right? Now you see, in this case, what is speed beta? Again, how can you find out velocity? Slope at any point. So here, because it is making a acute angle, speed will be positive. But I already got to know that acceleration will be negative in this. Here you see, it is going to make obtuse angle, guys. So speed will be, velocity will be negative, acceleration also negative, right? In this case, you see, again, acute angle, speed is positive, A is also positive, guys. So whenever velocity and acceleration are in same direction, what will happen to speed beta? Speed will increase. So in which region? In second region and third region, speed will increase. Whereas in first region, speed will decrease. So what I can say? Speed, the particle speeds up and slows down two times, it seems. So see, here it is slowing down. Here it is speeding up. Again, it is continuing to speed up only or not? Yes or no? Once it has slowed down, particle speeds up two times. Is it speeding up two times? Yes. And this part, if you take, sorry, this part, no, I'm really sorry. Here you will get acceleration positive, guys. Now you see, in this region, speeded up, speed down, then here also speed down only. Which part it is again, we cannot say exactly. We can take this is speed is positive, velocity is positive in this case, acceleration you will get negative. This part, if I take this part, I cannot definitely say it will be negative because it will be, you can take something in this manner. So there is a possibility there. ठीक है. Displacement time graph, choose the correct option from the following. So one thing is for sure, guys, what I can tell is here velocity is positive, velocity is negative, velocity is positive. This so anyhow we can tell because velocity at any instant can be found out by using the slope because displacement time graph is given. Whenever velocity and acceleration are in opposite direction, what is going to happen? Speed will be decreasing, right? And when velocity and acceleration are in same direction, speed is going to increase. So you see first in this case, speed is, acha, from here you see, initially there is some speed, guys. It got decreased, it became 0. Then again you see it will get increased but in opposite direction, right? Till here, till some value it will increase. Then again it will decrease, it becomes 0. Then again it will increase, guys. So there will be some intermediate position in the second region. So first it decreases, then increases, then starts to decrease, becomes 0, then again it will go on increasing. So the particle speeds up and slows down two times is correct again, guys. Fourth one will be correct. See, in second region, actually they should have given in a proper way. They should have given something like this. Should have given something like this, guys. Then it would have been proper. Okay. So as you can see from here to here, slowing down. From here to here, it will increase. From here to here, it will again slow down. From here to here, it will increase. Okay. So there is in second region, there should also be one more point like this in order to separate them. So in second region, speed will increase as well as decrease, guys. Okay. So both first statement and third statement will be correct statements. Understood, all of you? Yes or no? Actually, graph would have been like this. Okay, maybe slight disturbance. Matlab, you might not have given it in a correct manner, but you should get it like this, guys. Is that clear, everyone? Next case you see. A car starts from rest, accelerates on a straight path with constant acceleration for some time, again decelerates with constant value b. I have shown it, guys. Time elapsed is t. Then what is the average velocity they are saying? If you can just represent it in this manner. Initially, it is starting at rest, guys. So u value is 0. It is accelerating with some acceleration a. So obviously it will move in this manner. It is accelerating. Now it is going to attain some maximum speed. So as soon as it attains some maximum speed, it will decelerate now with a rate b. Whenever velocity and acceleration are in opposite direction, object will move in the direction of speed with decrease in the direction of velocity with decreasing speed till its velocity again becomes 0. So what they have given, it started at t is equal to 0. The total time elapsed is given, which is t. They're asking what is the average velocity. So did it move in a straight line? Yes, without reversing its direction of motion, guys. So what we can tell in this situation is from here to here it is accelerating, from here to here it will be decelerating. This is the total displacement beta. Okay. So what will I get? The length, the total length again, if you just solve for it, guys, if you apply v bar is u bar plus a bar into t, right? So you are going to get the total length of the journey as total length. If I take, you will get it as half alpha beta ab divided by a plus b into t square. This is the total length of the journey. They're asking average velocity beta. So it will be simply total length or magnitude. If I take total length divided by total time, so I'll get it as half of ab divided by a plus b into t. Clear, everyone? Just a second. Am I audible, all of you? Understood, everyone? So you can apply v bar is equal to u bar plus a bar into t here. You can apply v bar is equal to u bar plus a bar into t between these 2 points. So what will I get maximum speed as? The maximum speed, if we are trying to find, you will get it as, these are alpha and betas, guys. You can write, you will get it as alpha beta divided by alpha plus beta into t. This is the maximum speed. Okay. And average speed will be half of the maximum speed, which is half alpha beta divided by alpha plus beta into t. Understood, all of you? You have seen this case again. I have told you while explaining, while we were giving a review. I think I have discussed it, guys. Next case you see, which probably is the last question, I guess. A stone is released from rest from top of a very high tower. In first 3 seconds, stone travels x meters. Then for next x meters, time taken by the stone is how much they are asking. Okay. So in first 3 seconds, it has traveled how much distance, beta? X meters. So what I can write? Distance traveled in free fall. Is it half g t square or not? So it has traveled x meters in first 3 seconds. So I'll get it as 9g divided by 2. Now they're asking next 3 seconds. What is the meaning of next 3 meters, next x meters, beta? The distance traveled next x meters they have said. So can I say it is distance traveled for 2x meters minus distance traveled for x meters or not? Yes or no, yaar? A stone is released from rest from top of a very high tower. In first 3 seconds, the stone falls x meters. Then the next so time they are asking, no? So what can I tell time taken for next x meters? Can I write it as time taken to form 2x, time taken to cover 2x minus time taken to cover x or not? So what will be time taken to cover 2x beta? 2x if I take here, I'll get the time taken as root 2 into, right, root over 2x divided by g, right, minus of what we can write time taken to cover x distance as, it is already given as 3 seconds, I believe. Yes or no? I'll just show it somewhere in more space, guys. We have few more questions again, I guess. Okay. Two more questions are there, I believe. What they have given is if it is released here, time taken to fall first x meters. So from here to here, it is given as 3 meters. They're asking what is the time taken to fall next x meters. So will it be time taken to form 2x minus time taken to form x or not? So what I'll write here, time taken to form next x meters will be equal to time taken to form 2x minus time taken to form x. And what is distance traveled in free fall? Just now we have seen distance traveled in free fall will always be given as half g t square. So what will you get t value as root over 2s divided by g. So what are we going to get here? Time taken to complete 2x distance. I can write it as 2 into 2x divided by g minus root over 2x divided by g. So if I take root over 2x by g common, I'll get it as root 2 minus 1. And what is root over 2x by g? Is the time taken to cover first x distance or not? I think which is given as 3 seconds, I believe. So what will the answer be, beta? You will get it as 3 times of root 2 minus 1 seconds. This will be the time taken to form or time taken to cover next x meters of distance during free fall. Basic concept again, it's a very important statement, guys. Distance traveled in t seconds during free fall is given as half gt square. Understood, all of you? Yes or no? So answer will be how much? 3 into root 2 minus 1 we got. Yes or no? Let us see the next question. Two balls are projected in vertically upward direction with velocity 8 meter per second, 12 meter per second from same position at the same instant. Same instant. Separation between the balls varies with time. How it is varying? Whenever two balls are projected, first thing which you need to understand is both will be moving under the effect of gravity. So what will relative acceleration be? Relative acceleration will be 0. Okay. Now there will be some initial relative velocity. What is that relative velocity initially, beta? One is thrown with 8, other is thrown with 12. So initially there is some relative velocity. What is it? You can write 4 meter per second. Now they're asking us to find what is the separation between them. What I'll write? Relative displacement will be initial relative velocity into time plus half into relative acceleration into t square. Already relative acceleration is how much? 0. What is relative velocity? Initial relative velocity, we got it as 4. So is it going to follow a straight line graph or not? With positive slope, it will be following. First one will be the case, guys. But again, while it is coming down again, here also there is one logic, right? So you can get second one also as the answer. So let us again quickly discuss that in detail. I'll take it here, guys. From same point they have been thrown. From same point, guys. Just for understanding purpose, I'm taking them separately. One has been thrown with 8 meter per second. Other has been thrown with 12 meter per second. Obvious it is that both of them will be moving under the effect of gravity. Both of them have been thrown at t is equal to 0 only. Now, for what time will this travel, guys? Time taken to reach maximum height here. It will reach maximum because speed is less, means height will also be less only. So it will reach maximum height after what time? U by g or not? So 8 by g you can take, or 8 by 10 you can take after 0.8 seconds. But this you see here, this will reach maximum height after what time? This will reach maximum height after what time? U by g again if I do. So is it going to reach maximum height after 1.2 second or not? Yes. So what will happen? Now, from 0 to 0.8 seconds, always remember 0 to 0.8 seconds, the relative velocity will be 4 beta, 4 meter per second. At 0.8 second, this became 0, right? But at 0.8 second, it has some velocity again. Yes or no? Yes. So from zero point 0.8 to 1.2 second, the slope will be different again. It will follow straight line only always, but the slope will be different. Okay, so that is the reason I will go with which option? Second option as the answer. Till 0.8 seconds, one slope. After 0.8 seconds, another slope. Understood all of you? Yes or no? If not, if they are directly asking only the relative position, you can make it something like this. Where is this question? So two balls are projected vertically upwards. Then separation between the balls varies with time till one of the ball hit the ground. One of the ball is hitting the ground, guys. Right? So it will hit the ground after 1.6 seconds. Yes or no? If you just look back here, see what is the time of flight? For first case, for first object, if I take, time of flight will be given as 2u by g. Yes or no, beta? Arey, rara babu. The time of flight for first object is 2 into u1 divided by g, which is 2 into 8 divided by 10. You will get 1.6 seconds. Whereas time of flight for second object is 2 into 12 divided by g, which is 2.4 seconds. So till 1.6 seconds, they are asking us to draw the variation again. So till 0.8 seconds, it will follow a straight line with one slope. From 0.8 seconds till 1.2 seconds, it will follow some other slope. Then from 1.2 to 1.6, it will follow some other slope, guys. Okay. However, here they have given only two cases. You can go ahead with the second option, guys. Clear, everyone? Understood, all of you? Yes or no?
Yes.
We have covered motion in straight line. Tomorrow we will try to complete motion in plane. Again, as I said in the beginning of the class, these 2 days, Friday, Saturday, I may not be able to. I thought of taking 1 hour only today. I continued for 1.5 hours, right? So possibly tomorrow and after tomorrow, let us see, guys, how much time we can spare. Tomorrow we'll start motion in plane, right? By Sunday, I'll take a long session. We'll try to complete maximum things. Possibility laws of motion we will try to complete on Sunday. Then starting from Monday, we will take few more extra time such that whatever schedule has been given to you by next week, we come in resonance with that schedule, guys. Okay. So hopefully we can spare some extra time and we will do it. Okay. The next exam will be conducted on Friday, Saturday. We can do laws of motion. Sunday completely we can. Sorry, Friday, Saturday we can do motion in plane. Sunday you can write the exam, guys. Okay. Next exam can be written on Sunday. Clear, all of you? So we have done motion in straight line. We will soon complete motion in plane. By Sunday, we'll complete laws of motion. And I think first year syllabus is there till units and measurement, guys. So after that, we have modern physics again, which is also very important. Then after that, I think heat is there. Okay, so those are the topics which we are supposed to complete. Hopefully we'll be completing them soon, guys. Okay, we'll meet in the next session. Till then, take care everyone. Thank you, guys.
Thank you.
Thank you all.
Thank you, sir.